All right, next in the unit, we're going to talk about the length of an arc and the area of a sector. So for the length of an arc, we are talking about this length right here. So we're going to talk about the length of the arc from A to B. So the first piece of information that we're going to want to know is we're going to want to know the measure of A to B. So when I talk about the measure of A to B, I'm talking about the degree measure. How many degrees is it from A to B? And if you guys remember, the angle right here, this central angle is going to be exactly the same measurement as the arc right there. So we're going to kind of set up a proportion to say like a portion of the circle. We're going to say the measure of the arc from A to B out of the entire measure of the circle is going to be equivalent to the proportion of the length of the arc out of the entire length around the circle, which is kind of like the perimeter of a circle. And if you remember, there's a specific name for that. That's the circumference of a circle. And the formula for circumference is 2 times length. Arc length, I wrote AC, but I meant AB. That's my bad. Since the arc length is what we're trying to find, this is the part that we want to have isolated in our formula. So right now we have a portion out of the whole thing equals a portion out of the whole thing. So an angle measurement out of the entire angle of a circle, a length out of the entire length around the circle. So it's just a fraction out of the whole thing. So if I wanted to isolate this and get this alone so that I have a formula for how I could find the length of the arc, then I would just take this divided by 2 pi r and I would multiply that to the other side. So I'm going to say the length of the arc from A to B is the measure of the angle of the arc divided by 360 multiplied by 2 pi r. So it's basically saying what's the percentage of the circle you're talking about, so the angle out of 360, what percentage of the whole circle are you talking about, multiplied by the length of the whole circle. So what portion of the whole circle are we talking about? That is the formula. All right, a sector area is similar. I always think of a sector area as like a piece of pie. So right here, there's our sector area. So we're going to say area of sector. And so we still say the measure of the arc from A to B out of the entire circle. And this time we're going to say the area of the sector. I'm going to say the sector divided by the area of the entire circle. And the area of the entire circle is pi r squared. We've used that formula a lot lately. Pi r squared is the area of the circle. So if I wanted to isolate the area of the sector and say, okay, that's a formula that I want to find, then all I have to do is take the pi r squared and multiply that to the other side. So the area of the sector is going to be the measure of the arc, the angle measure of the arc divided by 360, because that tells us what portion of the circle, what percentage of the circle we're looking at, multiplied by the area of the entire circle. Oops, out of box the whole thing, not just part of it. There's our formula. So these are because they're fairly similar. It's just what portion of the circumference do you want? What portion of the entire area do you want? Okay, so now we're going down to the next set of problems. It's looking at this picture down here. So we have circle with a center of E, and they're giving us some information. They say angle TEG has a measure of 21 degrees. So TEG has a measure of 21 degrees. TR is a diameter, so TR perfectly cuts the circle in half. The diameter is a length of 12. Okay, so TR perfectly cuts the circle in half. This is a 90-degree angle. If TR is a diameter, that means that this is also a 90-degree angle. And so then if that is 21 degrees, then I can figure out that other angle by doing 180 minus 21. And so that's going to tell me that the other angle in the circle is 159 degrees. All right. I'm going to go ahead and label that the radius is 6. 6 equals the radius. And then I'm going to go ahead and mark what each of my arc lengths or arc measurements are. So we remember that central angles and the arc measurements are the same. So the central angle is 90. That means the arc is 90 degrees. 90, 90, 21, 21, 159, 159. Okay. So the arc measure from T to G is 21 degrees. The arc measure from A to T to R, from A to T is going to be 90. T to G is another 21. And then G to R is another 159. So add those all up and you get 270. T to A to R is half the circle, that's 180. And then I'll leave the last two for us to do in class. Okay, so the arc length formula is use the measure of the arc divided by 360 times 2 times pi times r. So we're going to have 21 out of 360. And then we're going to have 2 pi r, so 2 times pi times 6. And in the instructions, they say that they want the answer in terms of pi. So if they want the answer in terms of pi, that means you don't type the pi in your calculator, you put it on your paper instead. So the only thing I'm going to type in my calculator is 21 divided by 360 times 2 times 6. And you can type it in your calculator, you can type it on Desmos. So I can do 0.7, that's a nice decimal, so if you want to do 0.7, you could turn it into a fraction and do 7/10 as well. So either way is fine. I'm going to go ahead and do 0.7. So since I did not type the pi in my calculator, I'm putting it on my paper. 0.7. The units here were centimeters, and this is a length, so I'm going to say centimeters. All right, 270 over 360. 2 times pi times 6. So 270 divided by 360 times 2 times 6. 9. So my next answer is 9 pi centimeters. And then I've got 180 over 360 times 2 times pi times 6. 180 over 360 times 2 times 6. 6. So that's going to be 6. Okay. All right, for the we do the measure of the arc divided by 360 times pi r squared. So 21 out of 360 degrees times pi times 6 squared. Again, I do not type the pi into my calculator because I'm going to write it on my paper instead to have my answer in terms of pi times 6 squared. 2.1. So I'm going to say 2.1 pi. And then since this is an area, my units are going to be centimeters squared. All right, for the next one, 270 over 360 pi r squared. 270 over 360 times r squared is 27 pi centimeters squared. 180 over 360 was the next one. Pi r squared times r squared is 18 pi centimeters squared. So the formula is pretty easy to use. You just have to pay attention to whether or not your answer is in terms of pi. So if it says in terms of pi, do not type pi in your calculator. Write it on your paper. All right, and so go ahead and leave the rest of it. We're going to finish the rest of our notes in class.